So we looked at an example where we had the population standard deviation and we used a z-test, but most of the time that's really not the case. Most of the time our answer is no, we don't have the population standard deviation. And so in that case, we're going to use a t-test for a one population mean. So again, it says it is rarely the case that the population standard deviation is known when the population mean mu is unknown. When we don't know the population standard deviation, the best way to estimate it is with your sample standard deviation, or S. Just like when we don't know mu, we fix it with x bar. This changes the way our sample mean is distributed. When you no longer know the population standard deviation, you cannot use it in the formula. Where you see the population standard deviation, or sigma, in the test statistic formula, you will replace it with its estimate, the sample standard deviation S. When using S to estimate sigma, you now have more variability in your estimate. Instead of only attempting to estimate one quantity, or the population mean, we are now trying to estimate two quantities, the population mean and the population standard deviation. This increase in variability changes the distribution from the standard normal distribution, or z distribution, to the student's t distribution, called the t distribution. The test statistic for one population when your population standard deviation is unknown is the following. So you'll notice right now we see, let me highlight, right? We see S instead of sigma, but everything else is really the same. But now we have what we call degrees of freedom, which is n-1. So it says we now need to talk about the student's t distribution. Many times it's just the t distribution. The t distributions, there are infinitely many of them, are very close to the z distribution. They are bell-shaped and symmetric about 0, just like the z distribution. What makes the t distribution different from the z distribution is their spread. There is more variability in the t distributions than there is in the z distribution. This increased spread, or increased variability, is due to the fact that we are now estimating both the population mean and the population standard deviation, rather than just the population mean as in the case when using the z distribution. The reason there are infinitely many t distributions is that as the sample size increases, the spread of the t distribution starts to decrease. This happens because we take a larger and larger sample size. S, which is the sample standard deviation, becomes a better and better approximate estimate of sigma, or the population standard deviation. So the larger the sample size, the closer this t distribution looks sort of like our z distribution. So here is a summary of what happens. As n increases, S becomes a better estimate of the true value of sigma. As S gets closer to the true value of sigma, the t distribution decreases in spread. Thus, for larger sample sizes, the t distribution looking more and more like the z distribution. In fact, as n approaches infinity, the t distribution approaches the z distribution. So because the t distribution decreases in spread, as the sample size increases, there is a different t distribution for each sample size. Each particular distribution is defined by what we call its degrees of freedom, and we label it as just df. The number of degrees of freedom is equal to the sample size minus 1. So you'll see degrees of freedom. We can use the calculator to find the necessary t values corresponding to our required area and degrees of freedom. So remember we saw before with our normal CDF. Now we're going to look very similar to where we found the normal CDF, but we're going to go and look for TCDF. So that's a t distribution. And the how we enter it, right, is the lower limit, the upper limit, and now it's our degrees of freedom, which is n-1. Okay, so that's how we're going to enter this when we need to find a t distribution, or basically a p-value. This will give you the p-value. All right, so this is how we go through and find really the p-value. The way that we order and work out the hypothesis test, right, the significance level, the null, the alternative, that's all going to be the same. What's different is just using the different distribution.